And as I promised, our team leader of DevOps Automation Core team, Artem Davydov, is going to tell us the story how we improved our Kubernetes deployments. Artem, please start.
Yeah. Thank you, Alex. So, before starting my presentation, I want to ask you several questions. For example, who knows what kubespray is? Good. Who knows what the cluster API is? Good. Nice. So, let's start. The topic for today is from spray to play and our journey to cluster API. First of all, let me introduce myself. My name is Artem Davydov. I'm DevOps Automation Core Team Leader, Cloud Native Tech Lead in Altenar with expertise in GitOps, Kubernetes, CI/CD, GCP, and hybrid environments. A little bit more about my current position and about core team. So our team objectives are define and promote DevOps standards for automation, scalability, security, and so on. Also, we maintain shared infrastructure, enforce security policies, high availability of DevOps tooling. Also, we build self-service platform, create reusable infrastructure models and components. Also, we assist in ARC reviews to ensure alignment with standards and best practices. And also, I hope we will evolve into fully fledged platform team. So, what the problem we had? Yes. First of all, we are using kubespray. It's not like a problem, but we, as a company, as Altenar, has been outgrown with this tool. Also, we have a lot of Kubernetes cluster, and we need to find a way how to manage it more quickly without any downtimes and so on. And for example, we have for now 40 Kubernetes clusters, and the most bigger cluster, I think, has, for example, 40 nodes in it. And also, it's like a high execution time for maintain big clusters. The next problem was that kubespray as a tool runs from the local environments of the engineers, of DevOps engineers. And of course, we had several claims from the security team about patching management. They created for us a lot of tasks to update the packages inside the VM templates. What is kubespray? Kubespray, as I mentioned, is like a Ansible playbook with a lot of roles for creating and updating, managing Kubernetes cluster. What the cons of it? So it's not great for large scale. Slow provisioning and upgrades. If you have, as I mentioned, big Kubernetes clusters, you have to do it, for example, for 2 hours. And if you, while you are running, for example, the kubespray, you could get some errors while you are running this tool, and you will need to rerun it. So it's a very long procedure. Also, you cannot have a multi-cluster management. Only you can update or make some operation with cluster one by one. And it's high operational overhead. What's the pros? First of all, it's stable and widely used, works on bare metal, high configurable, and doesn't have vendor lock. Next one. We started to find the solution, how we can replace this great tool. We found several approaches, several tools. There are Cluster API, Rancher, and Omni. First of all, in Altener, we are using GitOps approach. Who does know what is the GitOps approach in the DevOps, in the good? So I want to make a remark. So GitOps is like approach when you store all the code in the Git repository, and this code applies by some tools in the moment when you, for example, merge it into master. And you have the one point of true of your infrastructure in the Git repository. So this was the main moment why we choose why the cluster API has been chosen. It fully GitOps friendly, without UI. We don't need UI. We don't want to click and create clusters by misclicking, for example, and make errors while we're creating. It's not possible for us. And if we are comparing these technologies, Rancher doesn't have GitOps approach. It currently has GitOps approach only when you populated the clusters with the Helm releases which you want to install in it. So Omni is a prepaid, it's a paid solution based on Talos, and we don't want to have another vendor lock. Also, Cluster API large scale and GitOps driven infra. What is the pros of the Cluster API? First of all, it's fully Kubernetes native. It's managed through the CRDs, GitOps for workflows, kubectl, and so on. Also, it's infrastructure agnostic. You can create the clusters even in AWS, in GCP, in Azure, vSphere, even on bare metal. And you can write your own provider as well. Full lifecycle automation. It has the scaling features, upgrading and deletion. It's like really fully lifecycle of your Kubernetes clusters. As I mentioned, GitOps friendly, easy to track changes with the version control. It has same workflow for cloud and on-prem. Once you write the code, you can apply this code not only in GCP, but you can choose another infrastructure provider and apply it, for example, in AWS or Azure. Highly extensible. If you want to write your own extensions, you can create your custom providers. For example, it's fully open source. And great for scale, it's designed for managing many clusters in one standard way. What's the cons? First of all, it requires solid Kubernetes and infrastructure knowledge. You have to be good infrastructure and Kubernetes administrator to solve the problems, to solve the issues which you can get. No built-in UI. For us, it's like not a problem. For someone, could be the problem. You don't have UI, monitoring, or something like extras. You have to integrate it by yourself, create models, create dashboards, and so on. Also, it's a funny moment that for creating new Kubernetes workload clusters, you have to have your own Kubernetes cluster. It could be the tricky to create first one, management cluster. Limited out of the box. It's less friendly for small teams without platform engineer skills. Your engineer have to be professional. Still evolving. API of the components of the cluster API still in alpha or beta, and with changes you have to check it and be prepared for it. You own operation burden. You own upgrades, maintains, and troubleshooting. So only you, and without any enterprise solutions, so on. Also, it, while supported, requires careful provider configuration and testing. What does it mean? It means that you have to have several management clusters to test your code. So it's like you have to have test cluster, stage cluster, dev cluster, and production. How it works? I created the small schema how it works. So, for example, you have a management cluster and the VMware vCenter, in which we want to have our new workload clusters. So you apply YAMLs, for example, management cluster with its core controllers created, 1 or 2 workload clusters in vCenter, or maybe in GCP or something like that. So let's see with what components it consists. So first of all, you see that it has cluster API controller, bootstrap provider, infrastructure provider, control plane provider. Each component relates to their own object recycles. So, for example, cluster API manages the cluster, bootstrap provider manage and adding new node, join the new nodes into the Kubernetes cluster. For example, it execute kubeadm commands. Infrastructure provider creates for you VMs, for example, in vSphere with the RAM size specified, with the specified RAM size, disk size, and so on. Control plane provider manage the nodes, control plane nodes, like installing their static pods, API server, and so on. Here's the custom resources of the cluster API. The high level is like a cluster. It has the link to infrastructure cluster. Infrastructure cluster is the low level. It mostly relates to the infrastructure provider. Then we have control planes, machine deployments. I want to make some remark. So machine deployments is the same as in Kubernetes deployments. For example, if you want to kill a machine in your Kubernetes cluster, machine deployment will create new machine. It's the same. So, what else? Before creating your own Kubernetes cluster, you have to choose the distro. the distro in which will be created, with which will be created the new cluster. We, for the first time, started to find OS-based images, because we already have an experience in Red Hat, Rocky, and we declined it because these images are really heavy. Approximately one image of Ubuntu or Rocky stores stores about 2.5 gigabytes, and when you create a cluster, when the infrastructure provider started to clone the template from this OS-based image, it took approximately 10 minutes only for one node. It's too long for us. Then we started to find another distro, and it was Talos. Talos is a great operation system, but as I mentioned, the Omni is like another project analog of the cluster API, but it's paid. And they have Bootstrap provider for creating new nodes with the cluster API, and they told officially on the GitHub that they will not support the free version, free open source anymore. So it's a pity. And the last one was Flatcar. Flatcar also Core OS based image. It's lightweight, immutable, and it's perfect for us. So, yeah, image preparation. We have chosen the distro. Now we need to cook it. First of all, how to do it? The way is to prepare image is with the tool of image builder. Image builder is another tool. It helps you to create image with already pre-installed Kubernetes components. Those 5 binaries of Kubernetes with special version that you want to be inside. Also, it could make some hardening of these images. So, as we are DevOps engineers, we don't want to make it always manually. Then we created pipeline. We created pipeline which automatically creates your image with version of Flatcar, with Kubernetes version, and after running, it uploads the images to vCenter. Now we can use it for creating clusters. So we have chosen the images, we created them. Now we need to find how we will install the cluster API in our management cluster. So then we found the cluster API operator. What is it? Cluster API operator is like another application, another service which manage cluster IP providers, those that I showed previously on previous slides. So it's like a meta operator which will install core, Bootstrap, control plane, infrastructure providers. Also, it has a version control, so it's very useful, and it handles installation, upgrades them, and so on. What benefits? It's like a single operator for all copy providers. and handles complex provider dependencies. So, next. Okay, we installed the cluster API in our cluster. Now we need to prepare all these custom resources. There are a lot of custom resources, so clusters with dependencies on machines, machine sets. Now we created customized templates. As you see here you can see the YAML files with the custom resources for cluster, for machine health check, and so on. So also we have the templates for machine deployments, machine templates in which we specify the RAM and the disk size. Also we have Helm moments. So it's like a Helm inside the cluster API. There is a Helm controller which installs Helm releases in your new Kubernetes cluster. So in that way, we install Cilium, we install cluster control. We install Airbox, for example, Flux, and so on. All of these customizers are gathered in one template, and these templates with the new clusters stores in the dev, prod, and stage environment. So the workflow is like all changes made through the Git commits, automatically applied by Flux. New cluster created using one standard template, which managed by our team. All the secrets stores in the HashiCorp Vault. And we have a multi-environment, separate configuration for dev, prod, and stage. Okay, let's talk about features and aspects of cluster API. First of all, DHCP. You have to have a DHCP network for new workload clusters. It needs to be the new nodes when they has been created with the cluster API needs to obtain API addresses automatically, but also they need to obtain DNS service with these DHCP requests and NTP servers. Ignition. Ignition this is a cool feature which can help you to patch Flatcar immutable operation system. So, for example, you want to disable SSH or, for example, AP tables or make some hardening in Flatcar OS. And you can do like ignition scripts and it works. Helmadon, I mentioned it. After the cluster has been created, you have possibility to install in it some Helm releases. In that way, we deliver Cilium network plugin. For example, you can deliver the Prometheus, maybe some infrastructure components. Cluster resource set is like the same as Helmadon, but it's mostly about raw manifests. So we have raw manifests in management cluster. For example, it could be certificates, SSL certificates, which will be applied in the new workload cluster. How we operate with workload clusters? First of all, engineer define cluster configuration in YAML templates, bring PR for the engineer team. If it approves, Flux CD and merge. Flux CD automatically syncs and applies configuration. Copy, manage cluster lifecycle and upgrades. And workload clusters get their own Flux installed for their own GitOps management. So, what we achieved? First of all, average Kubernetes creation time for now, like 10 minutes. Before it was like 30 minutes for new cluster, and with upgrades, we decrease time to upgrades, and now we have the feature that we can even downgrade the versions of Kubernetes clusters. No more runs from local environments. That's also a good security feature. Engineer needs to bring the code only, without running something from their own laptop. We increased security aspects by changing the OS inside Kubernetes clusters. Now we are using Flatcar. It's immutable, securely, with good community, with good developer community. Even they have several release channels, for example, for stable, for feature, and so on. It's a really good operation system. I want to show you a little bit more with the monitoring. As I mentioned, with Cluster API, you don't have any monitoring, any dashboards, and so on. You have to create it by yourself. So we created dashboards in Grafana. And when the new cluster has been created, it automatically added to these dashboards. Here you can see the Kubernetes version, the Flatcar version, the versions of the main components like Cilium, Flux, how many machines are in ready status, in not ready status, where the cluster spawns. You see the zones, data centers, and so on. Also, we monitor deployment zones. So we can create, as I said, that we can create the clusters over the world. You just need only vCenter or like data center, for example, in another country, and we can create there new Kubernetes clusters, and we monitor these zones, the accessibility, and also we have the alerts fully, the alerts on the machine statuses, on availability of zones, and we can receive it in Slack. So, plans for the future. We are thinking about developer platform based on Backstage. So, I hope we will create it, and every engineer, any engineer or any QA, any developer could create their own Kubernetes cluster for test purposes, for developer purposes, and just play with it. Also, the plans is like to migrate all on-prem clusters to the cluster API, and onboard bare metal infrastructure for provisioning. Now we are have a vendor lock on the vSphere, but it could be unlocked by implementing infrastructure provider on bare metal. Summary. First of all, I want to say that we are not against the KubeSpray. KubeSpray is a good tool for creating the clusters, small scale, simple clusters. But Altenar scale and needs have outgrown KubeSpray, and we require more automation, lifecycle management, and consistency. And Cluster API provides GitOps-friendly cluster management, seamless upgrades and scaling, better integration, with cloud infrastructure, and the migration unlocks operational efficiency and reduces manual intervention. So I want to say I would like to say thanks to our teams, to infrastructure team and to the toolchain team. That was really great collaborative work, and I think we solved it. Yeah, thank you.
Thank you very much, Artem. Is there anything your team is currently working to improve cluster API experience, like when it comes to authentication or integration to our common user management system?
Yes. Actually, we're starting to write and implement some Kubernetes operators. For example, when the cluster created, it needs also automatically added into the authorization systems. For example, we are using DEX, and when the cluster will be created, also it will be added in authorization system. Yes.
Thank you. Are you guys excited as I am? Any questions? Raise your hand who actually have to deploy their own Kubernetes clusters. Okay, so who have a question? Coming.
Hello.
Hello.
I just wanted to ask a question, yeah? And you made mention of the concept of when it comes to provisioning. I'm trying to actually you made mention of moving from your previous provisioning to cluster API. So there are two questions. The first one is, what's really changed apart from the deployment time when it comes to the aspect of resource management, talking about and other stuff that's when it comes to the management aspects, what really changed? Then the second aspect is, I wanted to know how you when it comes to the controller bottleneck, both, let me put it that way, how are you able to, do you separate, were there separations when it comes to multiple platforms, integrating multiple platforms, let's say from AWS, from Azure and other stuffs, like how are you able to mitigate such kind of, if there are certain things come up, let's say in the process of multiple integration from various platforms, because you mentioned that it actually gives you that possibility to integrate various platforms, yeah.
So as I understand the question, you ask about how to migrate the cluster from our previously provisioning, right? Yes.
What's really changed apart from the aspect of the deployment? We talked about speed now. We spoke about speed. I'm talking about resource management and other stuff. What's improved?
Resources for the new Kubernetes cluster could be decreased because of the more flexible installation via cluster API. That's first. Also, we changed the approach how we create the clusters. So previously we had code also in the Git repository, and we applied it via kubespray. It's like an Ansible playbook, right? Now you only need to have the code in Git repository and no more manually work. How to migrate from one on-prem to another on-prem? You just on load balancer move the traffic from the one cluster to another cluster, and that's it, I think. Thank you.
Okay, another question here.
Actually, like I'll start with assuming that you are deploying your stuff on the cloud, so either AWS or GCP. When would you say that you should go for your own, setting up your own K3S or Kubernetes, or going to an option like EKS, for example?
Okay, so when I show the slide with the management clusters, we store it in the GCP like GKA clusters. And from these GKA clusters, we spawn new workload clusters in vSphere on-prem. But you can do it and create new clusters in GKA, not in GKA, in GCP. But it will be not GCP. It will be like the typical VMs, but only in GCP cloud. The same with the AWS.
So you use GKA, you don't deploy your own control plane and your own ETC? And
No. We found that it will be less. It will be safely and.
Can I help you here, Artem?
Okay.
So yeah, basically we are solving the chicken egg problem. To have a cluster API running,
Right.
you have to have a Kubernetes to deploy other Kubernetes clusters. So the very first Kubernetes cluster that actually hosts the cluster API controller is GKE. So we don't have to manage that one. Then once we have one GKE cluster, we deploy cluster API controller on it. And from there, then we spawn Kubernetes clusters in our own infrastructure on-prem.
Thank you, Alex.
Okay, my question will be more infrastructure, a little bit about when you're using GitOps, right? So first point that when you're using the cloud and cluster API, what type of authentication that the users, when they try to access, right? What type of security that you apply here, which policies that you're using, right? When you are also deploying this using CID, when you are integrating this cluster API?
So we have templates for clusters, for security policies, which will be installed also with the new cluster. And what question was what? Is it safely for storing the templates?
I speak about the secret keys here on the GitOps, right? You already will have your secret key will be stored, right? And then it will be retrieved back. My point here is that if I am accessing now, right? What's policies that you are using to ensure that me are using the same secret key that to access this one, GitOps?
You'd have an access to the management cluster. So all the secrets to access in the work cluster stores in the management clusters, and we have a strictly access role based for it. So.
And in the deployment, do you are using any policy?
No, we are not using the secrets. All the secret stores in the HashiCorp vault, and in the Git repository, we of course don't store the secrets.
But this is security vulnerability because GitOps have this one. Okay, so this is a service attack by chance. This I giving you for me. This is a service attack because you need to manage the policy on the CID. Because this will be a vulnerability here, right? Okay, no issues. Yes, we can talk later.
Yeah.
Okay, no issues.
Yeah.
So you operate. Sorry, do you operate more of like a multi-tenant environment?
For example, can I create the clusters in one way? So some nodes will be in one cloud, another in another one? No, it couldn't be. So you only create it with one infrastructure provider, one cluster in right place.
Okay. So you don't have an issue with your credential management and stuff. All right, thank you.
Another question here.
My understanding of what you're talking about is something which is mission critical to the business of Altenar. How have you handled the human resource side of this? And at several levels, in terms of recruitment, in terms of training, in terms of managing the whole process to ensure the quality assurance of what you're doing. And I'd be absolutely fascinated because your entire presentation is a whole series of technical decisions you've taken about what to use, what not to use. How do you actually manage that decision making within your department?
Good question, thank you. So we have ARC reviews process in our company, and any engineer, any developer, any DevOps who wants to implement new technology have to create ARC review, and we have ARC review committee which approves or not approves, or like ask to make some changes in the in this ARC review process, in this ARC review. So in Altenar we have big cross teams ARC committee with the security engineers there, with the architectures, with CTOs, and so on. So it fully going from the for this process.
Or maybe I can add a little bit here. As I mentioned earlier at the very beginning, core team that is led by Artem is the only team that we don't hire from the outside the company. You can only grow there and be promoted from any other product-related team. So when we formed that, Artem was one of the most experienced engineers we had, and that's why he was the best candidate to lead this team. And so the guys, they know how things work in Altenar already, and they have proven track of records of pulling off a similar product. So the small decisions, they usually taken within the team, but then when we have a working solution, that's where our review process kicks in, and then we can gather the feedback from all the stakeholders. We can see if we missed something before we actually roll it out to production.
Thank you.
Any more questions? Come in.
You speak about infrastructure agnostic. I thought you mentioned infrastructure agnostic at one point, right? When you describe a cluster, a workload cluster using YAML, how agnostic is it actually versus multiple providers? If you take that definition and you want to create a cluster in AWS or you want to create a cluster in vSphere, how much change do you have to do to the YAML, if at all?
First of all, you need to check the documentation for the as funny as yes, the documentation for the new releases if you are changing the version of the providers. But as I mentioned, you have the several layers of applying the components. The first layer is like a common layer when you specify the configuration of cluster, and then you have the reference for infrastructure provider. And for example, in our case, we only have one for now. We only have one infrastructure provider as vCenter, as VMware. And if you want to have possibility to deploy clusters, for example, in GCP, you need to install infrastructure provider for GCP, and also, yes, check the custom resource definition of those objects which are related to the GCP infrastructure provider.
But let's say there are two providers configured equally. When we only define the cluster, can I just change the provider and the name, and it will work from vSphere to GCP, or I need to change more in the actual cluster definition?
You need to change the low level, so low layer, so only infrastructure moment.
So when it comes to the cluster itself, it's actually quite agnostic. You change two parameters and it works in the other cloud. It's pretty cool, thank you. I saw there was one more.
Yeah, first of all, thank you for this presentation. It's very huge journey that you make. And my question is, how long did it take from idea to actual implementation, and which stage took the most time?
Good question. So, we were two engineers with the great idea and a really big queue with the tasks for upgrading Kubernetes clusters, which were made from the security team for updating the clusters. And we were bored to do these operations manually every time with 2 hours maintain Windows and so on. And from idea to the first cluster, I think it took mostly 3 months. Mostly we were stuck with the troubleshooting for the first time. You have to check a lot of logs in each provider, like finding what happened with with clusters, why it didn't spawn, it didn't create. Then also we spent a lot of time with the comparing API references between a lot of API with a lot of custom resources. So, you know, like a meme when the man just trying to figure out references in some detective, you know, that was the same. Yeah, that's it.
So 3 months basically, and 2 people.
2 people, but yeah.
Any more questions? Oh, sorry.
Thank you. My question relates to more of the managed clusters and the home lab cluster. Like someone like me, I'm a software engineer, but most times I like dabbling into Kubernetes and other stuff. And I wanted to know, at what point do I need to move from my more of a home lab cluster to a managed cluster? Because I kind of feel that a managed cluster at the long run would handle more skill than me doing it on the home lab. Let's say spinning up a Linux server on a Hesna, installing Proximox and the rest of that, managing the whole cluster myself. At what point should I look at moving to cloud? Because personally, I don't like being vendor locked in any of the cloud provider, be it AWS or GCP. That's why I tend to try to manage most of the things I do within my own home lab or stuff like that personally. At what point, when it comes to scale, should I consider moving from home lab to managed clusters, or is there any workaround for me to, get over that?
I got it. So, trust me, you don't need it. It's very complicated, and mostly for the big companies with a lot of traffic and so on. So, my suggestion is like to use, for the home lab, you could use a Minikube, K3S, Talos. Yes, you can create the clusters with Talos. It's really, it's a release to create it. For the clouds, I don't know. I think you will spend a lot of money from your pocket to create the clusters in the clouds. So just need to find a solution when you can create the clusters on your laptop, on your PC.
So is more advisable to run the managed cluster on the cloud rather than having your own cloud, setting up your own on a private cloud on your own?
Yes, you wish, yes, you can do it.
All right, thank you.
All right, more questions?
So I just wanted to just find out, at what point in time do you from your wealth of experience, at what point in time do you think, even if you are not a big enterprise and company, you should make that move when it comes to, your traffic? So what kind of traffic do you think will make you to make such kind of move?
Okay, I got it, but this topic not about high load and about RPS, for example, on the project. In Altenar we have a lot of clusters and you need to spend a lot of time to maintain them. So, for example, you're a small company, you have 3 environments, dev, stage, prod, and KubeSpray is a good tool. Why not?
So if I have, let's say, about 13 clusters, and I have about the same I have dev, I have staging, I have production.
I suggest to stay on the KubeSpray.
All right, thank you.
KubeSpray is a good tool. We're not against it. We are still using it in some installations.
Maybe I can add here, like anyone who onboarded Kubernetes, they probably had to make this decision. Some companies, they go, especially like if it's a banking or high security, when everything has to be on premise. You can have one big cluster, and then you isolate namespace, network policy, and you use this one big cluster for all the teams within the company. And then maybe you have 3 of them in total, dev, stage, prod, and that's it. So in this way, you don't really need to deploy more and more clusters, and it's easy to manage them the way they are. And the other way of doing it is when you have a lot of small Kubernetes clusters, then you have challenges and you have to make sure that the security is the same across all the clusters, the network policies are the same across the clusters, the authentication. So the way we do it is partially solved by Flux CD, but spinning more and more clusters for more and more products, that's a never-ending story. So we have to face it day to day. And more clusters you have to maintain and update. And this is the signal when you have to look for the optimal solution, that you maybe have to invest once to set it up, but then management and day-to-day operation costs, they go nearly down to 0. All right, thank you, Artem. Thank you very much. It was very technical and very interesting. And I hope you enjoyed that. That was the last presentation for tonight. Go and check if we have any beer left. Feel free to hang out a little bit here, and we're good for today. Thank you very much.